So what we have here is I got two containers just holding water. So Isaac has this big clunky beaker, and I've got this cute little 50 milliliter beaker. Okay? So what's going to happen is that he is going to dip water in here and pour it into mine. I'm going to take water from mine and pour that into his. Okay? So if you want to consider his being like the forward reaction, mine's going to be the reverse reaction. Now, so in this situation, this is somewhat analogous to concentration. So he has a certain height of water. I have a certain height of water. Mine's very much lower. His is a lot more water in it. So what we can do is keep track of what's going to happen to these heights as a function of time. So he's going to fill up, he's got this much bigger beaker, and I've got a much smaller beaker, but I have less water. So what's going to happen to his level as a function of time? It's going to go down. Mine is going to go up. Okay, so you ready? So get water in yours. Just get as much, get as much as you can. Okay? All right, now you pour yours in mine. I'm going to pour mine in yours. Okay? So keep going like that. So eventually what's going to happen? They're going to even out. Okay? All right? So keep going. I'm not done yet. So initially, okay. Oh yeah, filling mine all the way up. All right? So we're good. So now if you were to look at this in terms of a graph, in terms of like if you were considering volume versus time, okay? So mine started off low and mine climbed. Isaac started off high and his went down, right? Now, eventually, what's that graph going to do? It's going to level out. Okay, they're going to intersect, but eventually they're going to level out. Now, when that levels out, I'm not saying the reaction has stopped. This is going to be an important thing. I'm not saying the reaction has stopped. All we're saying is that the forward and reverse rates of these reactions are going to be the same. Now, if we reverse the reaction, now, you get mine, I get yours. Okay? Now, if we try and reverse the reaction, now what's going to happen? Yeah, his is going to go up, mine's going to go down. So, if we change the system, okay, like for example, we could change the size of the beakers, that's going to be a different rate function. So this would be a particular one for this size of beaker and that small beaker. If we both had equal sized beakers, that would be a completely different set of graphs. But what I want you to get out of this is one idea, is that these change as a function of time. But eventually, the graphs are going to level off. We're going to reach a point of equilibrium. Now, I don't want you to think that every reaction does that. If you drop a piece of magnesium into a solution of hydrochloric acid, the hydrochloric acid is not going to decompose and you're going to reverse that reaction. But what I'm saying is that you have to get used to the idea that certain reactions can reach a point of equilibrium where you could have forward and reverse reactions going on at the same time. Got that? Good? Okay, back we go.